Ooh, ooh, look at the shiny new whiteboard. Oh, it's so beautiful. Come here, whiteboard, I love you. Oh, hi. Hello and welcome to a calculus tutorial by Physics Man Education. I'm Physics Man, and in today's tutorial we're learning about completing the square. Now in a previous tutorial we talked about how you can find the roots of a quadratic function by factoring that function. And then if each of the factors, whenever either of the factors goes to 0, would give you one solution of x when the entire function goes to 0. But a quadratic function in general is not always easily factored. So we developed this technique called completing the square. And completing the square allows us to deal with quadratic functions in a couple of different ways. First of all, we can use it to derive the so-called quadratic formula, which the quadratic formula can be used generally to find the roots of any quadratic function. But aside from that, we can also use completing the square to change a quadratic function into the so-called vertex point format. And we're going to generally do that today, and then we'll talk about some of the information that we can extract from the quadratic function when it's in this format by looking at the equation we wind up with. So, the first step, whenever you're dealing with a particular function, is to write the function down. We're gonna work today with the general form of the quadratic function. But we're also going to need one additional concept. And the additional concept comes from this simple fact. This is what we call a perfectly squared quadratic function, where d is any number, it's a parameter, and x is what it is a function of. But this, of course, is just equal to x plus d times itself. Now, if you put up with one more step of tedium, we'll expand these brackets. So x times x will give us x squared. X times d plus d times x, which is just the same as 2d times x. And finally, we'll have d squared. Now this would be the general format of a perfectly squarable quadratic function. Now, if we compare this to the general form of a quadratic function, the first thing we notice is that we require the coefficient of a to be 1. And a isn't 1 here. So what we're going to do is we're going to change this into something a little more similar to this by dividing the entire equation by a. So if I divide the entire equation by a, I have to divide the left side by a. Ax squared divided by a, well, the a's will cancel, which is an excellent start because now we have a coefficient of 1 here and a coefficient of 1 here. We've already made our expression a little more similar. Now, we have to divide the other terms by a as well. And unfortunately, they don't cancel out right away. Now, if we compare these two functions, we can say, and when I say function now, I mean just the right-hand side here compared to this. We can see that for this to be true, we require b over a to equal to 2d. So let's talk about that here. We'll say b over a has to equal to 2d. Therefore, we require d is equal to b over 2a, and d squared is equal to b over 2a squared. Now, c over a is not necessarily going to be equal to that in a general quadratic function. So what we're going to do, since we need to have this term in order to be able to complete the square, we're going to have to add the term or somehow insert the term into our function. And we'll do that like this. First I'll write y over a is equal to x squared plus bx over a, And then I'm going to deliberately leave a little bit of a space here that I'll fill in a second. And I'll include the c over a. But this is exactly the same equation. And in order for both equations to be simultaneously true, this has to remain the same equation, but I need this term to be added in. So if I add the term in, the problem I have is that this is no longer the same equations. But I can subtract the same term. Now, these would cancel to give the same thing again. And here's why that's useful. We can take this chunk of the equation and complete the square there. And that's exactly what we're going to do. So if this is d, b over 2a is d, then we know right away that y over a is going to equal, this entire thing will be x plus d squared, but d is b over 2a. And we have completed the square for this chunk, but we're left with a term b over 2a squared plus c over a. Now our final step would be to multiply the a back across, and I'm going to write this in two different colors. I'm going to write, first I'm going to write my y over, oh no, I don't need the over a, because it's going to be multiplied through. I'm going to write the squared term, and I'm going to write the not squared term. I'm going to write this part in red, so we'll have, I guess maybe I should make this a plus sign. And then I can just copy this chunk directly into the brackets. So we'll have 1 over a times b over 2a squared plus, and then c over a times a will just give me c. And this is the so-called vertex point format, because if this part here were 0, first of all, this tells me, I'll circle it in green here so you can see what I'm talking about, but that tells me the x value at the vertex of my parabola. And if the vertex is 0, this tells me, or if this entire thing is equal to 0, this tells me the y value of the vertex point. And that in itself is pretty cool. So that concludes this particular tutorial. I hope you found it useful. I hope you understand completing the square a little bit better. In following tutorials, I'll show you an example of how to complete the square with a particular quadratic function, and also show you how it's used to derive the quadratic formula. Thank you very much for watching. This has been a production by Physics Man Education. I'm Physics Man, and I'll see you in the future.